What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. Today, we're going to be talking about the hydrolysis of a cyanide. Now I get this question a lot, and a lot of times they show just the starting product and our final product, and they don't actually show you the steps on how we undergo the hydrolysis. To form, spoiler, we're going to form a carboxylic acid when we do the hydrolysis of the cyanide. So let's go ahead and jump into it. Now, what I'm seeing here is I'm seeing a good nucleophile, okay? I'm seeing a primary here. I see a good leaving group here. These are excellent conditions for, what do you guys think? SN2, E2, SN1, or E1? Go ahead and let me know what you think. These are excellent conditions for an SN2 reaction, okay? Now we want to have primary, that's going to be the best. SN2 can still happen during secondary, depends on the conditions. Tertiary is definitely a no-go. And for SN1 and E1 reactions, we know we're going to want to deal with something that's maybe tertiary. You can definitely do secondary, but I would much prefer doing tertiary. So we went ahead and narrowed it down. So what I'm seeing here is I'm seeing this negative carbon come after this bond here to do an SN2 backside attack to change the stereochem. Here we don't care about the stereochem, so that's a plus. Okay, now this is what our group is going to look like when it adds on. Before it added on, we had a spectator ion out in front. We had our carbon triple bonded to our nitrogen with a lone pair on the carbon to give it its negative charge. That's what I drew there, okay? So what do you think our next step is going to be? We have an H3O+. plus. Go ahead and give this a try if you haven't already, and try to work it out on your own. Okay, so let's see what we get here. So here is an H3O+, plus, just like that. This nitrogen here has a really good, strong lone pair that can go and grab a hydrogen, okay? So when we do that, we're going to get this group out here. Here's our carbon, triple bonded to a nitrogen with a hydrogen. This is going to put a positive charge on the nitrogen, and it's going to form some H2O. Okay, now I can actually draw a resonance structure here. I can go ahead and do that for us. So if I were to put a lone pair onto that nitrogen, it's going to make the nitrogen happier. And this carbon is now going to be missing a bond. It's only going to have 3 bonds. And we're going to look like this, okay? This is going to help us figure out where this water molecule is going to attack. Well, we know where water is going to attack the carbon because the carbon would rather have 4 bonds than have 3 bonds, okay? So this carbon is much worse at holding this positive charge than the nitrogen would be. Okay, so now we know where the water is going to attack. What I like to do, I'm just going to go ahead and erase this little arrow here. We know this is going to happen during our resonance. I always like to draw this water molecule attacking this carbon here, just like this. Now, it's not going to matter. I just like to do this because then I can show why these electrons also move on to there. So that nice flow of electrons that we get right there. So what do we get? Here's our carbon. We now have a double bonded to an N. We still have a hydrogen. We got a lone pair on the nitrogen now. And here is a water with the hydrogen. 2 hydrogens there. Great, so carbon's all fixed. Now we have this lone pair from the nitrogen that can come grab a hydrogen again. Same story, right? That lone pair, really good at grabbing that hydrogen. We got an OH group. We have a double bonded N, and now this nitrogen has 2 hydrogens. Again, positively charged, okay? Now, what are we going to do? We can actually react another species of water with this, okay? So what we could do is we can take another water molecule with its 2 lone pairs. We can take this and have it attack our carbon just like that. So again, this is going to cause this to get pushed up to there. Let's see what we get. Here's our carbon, OH. Here's our new water molecule, OH2. And we still have now our single bonded nitrogen with 1, 2 H's and a lone pair. Great. So this just keeps on going, right? Now this nitrogen can grab here. Let's see what we get. So now we have this carbon with an OH, OH, NH3 plus. Okay, good leaving group because this is going to form NH3. NH3 will be just fine on its own. So I can bring this down, form a double bond, and kick out our nitrogen. Okay, so now I have, here's my carbon, here's my double bonded oxygen, positive charge here. So I can see that I'm forming the carboxylic acid, right? This NH3 is all stable on its own. The last thing, just to finish up this problem, this can come grab our hydrogen here. And our final reactant is going to look like, let's go ahead and do it. We're going to get this. Here's our carboxylic acid. And now we get NH4 plus. That's ammonia. All right. There's the hydrolysis of our cyanide. Thanks, guys.